Olá, muito boa tarde. Sejam bem-vindos ao segundo dia do nosso encontro aí do webinário sobre economia circular. Nossa sessão internacional, a segunda sessão vai acontecer hoje. Meu nome é Felipe Boa, eu sou presidente do Instituto de Economia Circular de Eletrônicos. E hoje nós vamos falar sobre tecnologia e sobre software no contexto do movimento. And he's been recently issuing a report on the digitization for the circular economy, sort of bringing out a roadmap on how these topics are going to roll out within the European Union. And so I'm very happy to have you here, Stefan, and to listen to what you have to share with us in terms of how the digitization and topics on recycling 4.0 might be relevant within the next years to come on the forefront of new innovation. Stefan?
É o seguinte, a internet fez um pico aqui. Todos os móveis fez um pico. Não entrou, a gente vai reiniciar e vai fazer de novo, tá? Abertura.
Tudo bem?
Beleza?
Avisa ele lá.
Vamos avisar lá. Stefan, you listening? You listening? Ok? Stop. Please. Você está falando para ele que a gente vai fazer de novo porque...
Ele pode me ouvir?
Pode.
Well, Stefan, I think it got we had some issues here, so we're just going to restart. I think they didn't start the session right, so I'm just going to do the whole thing again, and then
Okay.
I'll put you on the spot again. Okay?
Okay.
O modem está posicionado, mas o sinal também está horrível.
Chuva? Pode ser. Agora voltou. Peraí. Deixa eu agora. Vamos colocar a contagem regressiva de novo?
Vamos fazer de novo, ó.
Peraí, vou colocar.
Porque não entrou pós da internet.
Bom, vai lá.
Vai.
Vou colocar só uns 5 segundos.
Boa tarde a todos. Sejam bem-vindos ao nosso segundo dia do nosso webinário de Economia Circular. Hoje nós vamos continuar com uma segunda sessão internacional e o tópico hoje vai ser a tecnologia. Queria aproveitar para talvez conectar um pouquinho com a sessão de ontem, onde a gente ouviu sobre operadoras de sistemas de logística reversa na Europa. A gente trouxe alguns benchmarks de como esses sistemas podem ser organizados, seja de forma coletiva, seja de forma individual. E isso é um tema que é no coração do IES também, que a gente educa e promove, que a gente ajuda fabricantes, importadores, varejistas e operadoras de sistemas de fazer isso com excelência e de aproveitar, obviamente, de software e tecnologia, que é o assunto de hoje. A sessão de hoje vai focar basicamente na ideia de como a digitalização pode trazer benefícios e eficiência ao nosso setor, a operações que estão rodando dentro da economia circular. E a gente vai primeiro ter um palestrante que era previsto para dar uma palestra, um keynote speech dentro de uma conferência do WeForum esse ano, que não aconteceu. Então a gente tem o privilégio de ter ele aqui com a gente, compartilhando conosco em primeira mão as coisas que iriam ser faladas ali. Ele vai falar sobre um roadmap de digitalização que está acontecendo na União Europeia e dessa forma já trazer um pouquinho do framework de policies e ao mesmo tempo dar algumas benchmarks e algumas ideias de aplicações práticas que eles encontraram dentro da pesquisa feita por eles. Para que essa interação flua um pouco melhor, eu vou mudar então o idioma para que os 3 palestrantes possam seguir a gente. And consequently, I'm going to continue in English. So I just mentioned we're going to have as a first speaker Stefan Zipka here. Stefan has large experience in digitization and extended producer responsibility. He's been working for 10 years in this sector in many European countries, including Serbia, Hungary, and currently Belgium, where he's active for the European Policy Center. And the European Policy Center is a think tank based in Brussels. They're doing work for the European Union, do a lot of policy research related to several topics. But one of the topics is circular economy, and Stefan and his colleague Annika Hedberg have been working on this topic on digitization of the circular economy, and there's been a recent report that came out in 2019 that I recommend to read, which has a lot of nice insights into what's happening in terms of innovation in the field and also what's happening in policy. But I'm sure Stefan is going to give us a good review of what's in the report and also maybe some additional insights today, as we're going to be able to hear from him now live directly. Stefan?
Thank you, Philip, and of course, happy to share some of our findings on this very interesting topic regarding digitalization and circular economy. And this is something that that the European Policy Center, an independent policy think tank based in Brussels, has been working on extensively in the last couple of years, and we are still doing so. So, without any further ado, I would like to then also show a presentation that could help. Yeah, so basically, when we talk about digital and circular, this is basically how we can visualize it, in a nutshell. So currently, we are experiencing these two transitions: a green transition, and also including circular economy transition, and also the digital transition. Both of these are happening. We can experience them in our daily lives, especially the digital transformation. But also there are, the focus of our work was on the EU, of course, but indeed there are these already policies and agendas on circular economy and digitalization. However, what we have noticed in the last couple of years that these two agendas, these two policies are not interconnected enough, let's say. So there are inconsistencies, or they do not speak to each other, and then certain synergies are not exploited that could otherwise be the case. So the whole idea is that if we merge them into a digital circular economy, that can provide a significant boost to this transition to a more sustainable as well as competitive Europe. And of course, I think this would be the same with other countries, non-EU countries, where achieving this sustainable and competitive economy is something that arguably we are all striving for. When we talk about digital circular economy, this is again a way to visualize it. So we can think of it as, we can look at it from the product life cycle point of view. And what our research shows is that digital solutions can play an important role throughout the life cycle of a product. So whether we talk about the design phase, where artificial intelligence can actually be used to support, to speed up the research and development of more sustainable materials and products, or digital or design, eco-design itself. Design of green products can include digital tags that can be used to access certain data when product becomes waste, for example. Or if we talk about production, we can use 3D printing, or in use and consumption, we can use, producers can scan a tag on a product with their smartphone to obtain valuable information, for example, how to repair a product or where to bring it when it becomes waste, what to do with the product to manage it sustainably in the end of life phase. Or we talk about reuse, remanufacturing. Again, if you have Internet of Things, connected machines, you can actually gain valuable insights on regarding this equipment, how to repair it, to remanufacture it, and so forth. Or you can also ensure predictive maintenance, so that you get an information about the product that is providing certain service, and you can repair it in advance and therefore prolong its lifespan. Lastly, when a product becomes waste, there are already opportunities with robotics, with artificial intelligence, to sort it out more efficiently, to dismantle it more efficiently, to identify whether there are hazardous substances and so forth. So there are opportunities when it comes to merging, connecting digital and circular. And also, this is another way to look at this. So what can digital do for circular economy? It can improve knowledge, connections, information sharing. It can make businesses, products, and processes more circular. This is similar to the previous slide you saw. And lastly, it can empower and influence citizens and consumers to take a more active role, especially when it comes to their behavior, their engagement, to actually support this a more circular economy. And there are already cases that support these claims. So, for example, Circularize is an organization that has developed a blockchain-based solution where, for example, you can, if there is a QR code on a product, you can scan it and obtain valuable information. For example, is there a mercury in a screen or not? Blockchain is important because it can you can avoid potential fraudulent behavior, and it ensures more transparency when it comes to this sharing information. What is interesting about Circularize, it's not a database. They provide a pathway, blockchain pathway between producer or the company that has this data and the person who is asking for this information. So in a way, there is a balance between this typical problem, which is data sharing and data protection. This is an interesting case to consider in this regard. Then again, you can also use watermarks, different kinds of tags to scan, for example, a plastic packaging like a filigrane, and to obtain valuable information so the recycler can know what to do with the certain items. Accelerated metallurgy is a project that can it was not a project specifically targeted for circular economy, support circular economy, but the insights are interesting because it proves that you can use artificial intelligence and advanced computing to speed up the development of new materials, which can then also be green materials, circular materials, and which is very important because usually with problem with eco-design, it takes a lot of time to develop standards, and it doesn't necessarily, these standards don't catch up with the new developments. So if you speed it up with the help of these technologies like AI or advanced computing, that could actually support also eco-design. Then again, you have examples where you can use predictive maintenance, so elevators can send information to the service provider so they can repair it timely. And then again, there is this Reach project, you know about the Reach database in the EU. So basically it's a database and there will be a smartphone app so the consumers can actually access information about certain information regarding chemicals also in certain products, so that can also guide their decision making. However, so there are considerable opportunities when it comes to digital solutions for a circular economy. However, there are also, it comes with caveats. digitalization basically will not automatically lead to greater sustainability, but there needs to be also a policy intervention and awareness of the potential rebound effects, negative effects of using digitalization and ICT equipment in general. In terms of the footprint, so we can think of energy consumption of our different gadgets that we use, smartphones, or also blockchain and artificial intelligence. But also it's in terms of purpose. What do we use digital transformation for? Is it a goal on its own? Or is it an instrument to achieve a wider goal, namely a green transition and circular economy? So this is something that we need to be careful and consider that we need to have a clear vision. For example, for the EU, we suggested that there is this kind of a clear vision for the EU to become a global leader in using digital solutions to achieve greater sustainability, and of course a goal followed by a vision on how to proceed on this. But basically, what's important is to think of that there is, in a way, that we need a sustainability review of the digital transition. So we take that angle, but we also we need a digital review of the circular economy transition. So we need to take both angles to ensure that there is really a successful transition to a circular economy and the Green Deal. Which again means that if you look at the lower right corner, this basically means that first we need to think of how to green the ICT itself. So how to make our equipment more energy efficient, how to make our ICT equipment more material efficient, because we know that there are critical materials contained within. So we need to think of the design again and how to use them, and how to actually ensure that these products retain their value, the materials, and also don't consume a lot of energy, therefore not to emit a lot of greenhouse emissions and other emissions. Then it is also important to green the digital agenda itself, to ensure that the policies on digital consider sustainability, so that when we invest in digital solutions, we also keep in mind that we invest in green digital solutions, and that also they should be aligned with the whole sustainability agenda and circular economy. It's also important to consider that digital tools can improve policy making itself. So, for example, you can use digitalization to improve public procurement, and it can support green public procurement, because you can access information that can be valuable for public procurers to distinguish between different eco-labels and different products, and that can actually boost development and of these new green solutions. Lastly, we need to think of the industrial agenda, and we need proper investments and conditions to support the industry, that it becomes both green and digital, that there is an uptake of green digital solutions, but also that it's aligned with this kind of overarching goals. So this is an important point to make as well. And then we, in the course of these different projects we conducted, we really have a lot of recommendations, and it's not possible to dive into all of them, but we can actually, I could mention a couple of them. So we can use that it's important, first of all, when we talk about sustainability review of the digital transition, we need to use the EU's financial tools. You can think of any other public investments to support digitalization for the circular economy. Now you know that there are discussions over the multi-annual financial framework of the EU, how to use EU's budget in the next decade. So it's important that we invest the money to serve the common purpose, the common goal, and that it doesn't go against the green transition and circular economy in that sense, including investments into electronics, into our infrastructure, and so forth. Then you may know about the data space for a circular economy. So the Commission, as part of the Green Deal, has suggested this data space not only for circular economy, but for many other applications. But there will be this kind of a data space for circular economy, which doesn't mean that it will be a single technical solution, but it will be a sort of a framework to discuss how to standardize data sharing, data collection, and because that is indeed key to standardize data sharing, accessible data, so that you can collect it, share it, access it, treat it, analyze it more efficiently. So this is something that is ongoing and definitely needs to be on the top of the EU's agenda when it comes to this discussion. Then it's important to reduce the barriers to digital enabled services. We know that there is a huge opportunity with servitization. It's not, again, doesn't come automatically, but still there are significant opportunities to use services instead of products. Because yeah, we need lighting, we don't need light bulbs. We need mobility, we don't need cars. That can actually, this kind of an approach can support circular economy significantly. But we need to reduce the barriers, which can be of different sorts, regulatory or financial, taxation, and so forth, to actually support this kind of service-based, green service-based business models. E-commerce is a huge challenge. It totally changes our mind, how we look at things, how we trade, how we consume. So it also, we need to ensure that products that are put on the market via e-commerce are green, and that, of course, they are adhere to the rules, including extended producer responsibility rules, and this is something that is still to be achieved. Again, we are not alone, and national economies that cannot be isolated or shouldn't be. We live in a global world with global value chains, despite regardless of the corona crisis, still the case, I would say. So we need to ensure that there are global rules and standards also for the circular economy, how to use digitalization for that purpose. Now, when we talk about digital review of the circular economy agenda, we need to explore how digital can support producer responsibility schemes. And here we mainly think about sharing information between producers and waste operators or repairers or consumers. This is something where digitalization, digital tools can actually provide further support. And then again, regulatory mechanisms can support this uptake. Eco designs, again, as mentioned, can actually provide, you can use, for example, eco design rules maybe at some, not now, but it can be a possibility to require that tags are inserted into products that can contain valuable information, or you can use digitalization to speed up the eco design process itself, as mentioned beforehand. Then we need legal waste shipments, and we need to facilitate that the waste shipments are more faster, but then to avoid illegal waste shipments. And this is again where digitalization can play a significant part by, for example, switching to electronic notification systems instead of paperwork. You can actually streamline, speed up this kind of shipments and create the economy of scale, support better management of e-waste, but also it's important, of course, to avoid any kind of fraudulent behavior. Lastly, creating a market for digitally enabled solutions for circular economy. We need public procurement, we need taxation policies that are favorable to the business case, so that we really have the uptake of circular solutions, but also innovative solutions for the circular economy. And then just think of these kind of solutions like green public procurement, taxation, and so forth. Sorry, yeah, there's actually one more. We need to also educate and upskill citizens and workers and SMEs to use digital skills. There is still a significant digital illiteracy, also including in Europe. We need investments to change the picture, and we need to increase citizens and consumers' trust in new digitally enabled solutions. This is not a blind trust. Of course, there are no reasons why people don't trust sometimes digital solutions or sharing data. But that being said, we can't achieve a circular economy without actually sharing data more across different value chains and about the product itself. It's important to share data, and then again, we need to consider this kind of squaring the circle to some extent, how to share data but protect it in the same way. It's difficult but not impossible, and part of this is also to change our approach to data, that there is more trust into this solutions, but of course justified. this is, in a nutshell, some of our findings when it comes to digital and circular economy specifically. Happy, of course, to discuss more and to hear your questions and any additional comments you may have. These are some of our latest publications on this topic, which are available on the website of the European Policy Center. And as Philip mentioned in the beginning, there is this ongoing work on specifically in e-waste and digitalization that the European Policy Center is implementing this project together with the WE Forum. And once this publication is finalized next year, it will be presented and it will also be made publicly available. So thank you once again, and looking forward to further discussion.
Thanks a lot. That was excellent. Yeah, I read the report, and I think it offers a great bunch of insights, so I recommend it actually to everyone to read. And Stefan just gave out the also the reference where to find it. We're going to do some questions on this later on, but I'd like to do a quick call on our efforts to actually collect a bit of money from our participants for a good cause. This session is supporting Instituto Livres, so they're operating in remote communities, also bringing technology to them to make their life a little easier and better. And I'd like you to support and contribute to the cause and help us making this a success as well. Our next speaker is Mark Menega. Mark has been working at the Institute for Sustainable Manufacturing and Life Cycle Engineering together with Professor Christoph Herrmann at the Technical University in Braunschweig in Germany. And they have been working for a while on digitalization of remanufacturing and recycling systems. Mark has been a coordinator of the research at IWF and is currently heading also one of the research groups. He's been there for over 12 years, so he's been with this project at the beginning, and I'm very curious to hear what he can share with us in terms of the developments in this research project. So Mark, very welcome, and we're looking forward to hear what you have to share.
Great, thank you. Can you hear me? All's fine?
Yeah, perfectly.
Awesome. Perfect. So yes, thank you very much for this introduction. I was willing to share some of our ideas in regard to the potentials of digitalization to support the circular economy. So we have several research projects in this area, and so I would like to share my understanding on this topic and also provide some examples here. So what do I want to talk about? I started my presentation obviously with a short motivation. So why do we need a circular economy? And maybe also raise the question, what can the potential, or what are the potentials of digitalization to support the circular economy? And based on this, I will then go a bit more into detail into the interconnection of circular economy and the digitalization, raising the term recycling 4.0, trying to provide my understanding of what I think recycling 4.0 is all about, and then with this also give some examples in this area. And I will finally conclude and give an outlook on this. So starting with the motivation, why we need a circular economy. I think it's quite obvious if we look at the global emissions, for example, on the greenhouse gas emissions, that especially the manufacturing of products is certainly a driver for the GHG emissions. So here we see the GHG emissions in different areas. The global GHG emissions that can be further differentiated into several areas like buildings, industry, and transport, and then this industry impact can again be subdivided. And as I said, besides heating and cooling of buildings and the transportation, the manufacturing of products is a main contributor to GHG emissions. So for this reason, it is necessary to find alternative ways to produce materials, and there especially the use of recycled materials is definitely a potential option. So if we look, for example, on the embodied energy of certain materials like aluminium, steel, copper, and so on, we can see that the embodied energy of virgin material in comparison to the embodied energy of recycled material is much higher. And this is more or less related to some aspects in terms of what can the circular economy provide, right? So the potentials that we have here is, on the one hand side, that we can provide, that we can avoid primary production through circular economy, and with this, use materials with less embodied energy. On the other hand side, if we establish an efficient circular economy, then it's also possible to avoid end-of-life emissions, like emissions to the soil, to emissions to the ground, and so on. I agree totally with Stefan that circular economy is not necessarily beneficial. There has to be some effect. If you look at, for example, the emissions resulting from potential recycling activities, they must be lower than the emissions that you can save from potential end-of-life circular economy activities. And the same is actually true for the digitalization. We can see this later on. So recirculating materials can reduce the environmental impact, certainly. But the question is, so what now can digitalization do in this context? So, as I said, shifting from a linear to circular material flow is potential, or provides potential. However, it's not that easy to establish efficient processes at the end of life stage, and that is in most cases related to a lack of transparency and knowledge at the end of life stage, because there's much information missing in order to implement efficient processes here. For example, in the end of life stage, you need product information about the contained materials of products. You also need information on which purities you potentially can achieve through recycling processes. And you also need information about the user behavior of a product. If you think of, for example, a used mobile phone, you would be willing to know how this mobile phone have been used in the past in order to choose a right or to take a right decision in terms of which recycling option do you use. Do you give it to the reuse section, or do you give it to the recycling section? Then you need process information on the one hand side of the recycling processes itself. So how much energy is used in the recycling processes? What are operating resources and potential joining techniques are also important, because if you want to recycle or also you reuse certain components of a product, then you will need to have knowledge on how to get those components out of a potential product. So, and therefore you need to know how these product has been joined in the manufacturing process. And finally, you need market information, because I mean, if you want to undertake recycling activities, there must certainly be a profit from a market perspective. So you need to have knowledge on which product prices you can achieve if you sell the used products on the market again. So as we see, we need a lot of information, and then the question is, what can the Industry 4.0 paradigm provide in this sense? So Industry 4.0, as you potentially may know, continues the development that has been started with the digitalization, right? So it provides the more potentials in terms of that you not only get information on what is happening or why is it happening, but you can also go or have a look into the future, right? So you can raise the question, what will happen, and how can a system autonomously respond to a certain development that comes out of the background of the system. So it's about not only visibility, transparency, predictive capacity, but it's also about adaptability. Now the question is, how do we bring together these two aspects? So circular economy on the one hand side and Industry 4.0 on the other hand side. So the potentials of digitalization are quite obvious. So we can achieve virtualization, decentralization, modularity, real-time capability. With this, we can increase flexibility and productivity or efficiency. The digitalization has been further developed in the past, since we had several developments that benefit the digitalization in the market, right? So, for example, we have the reduction of costs in terms of hardware, in terms of bandwidth, in terms of data handling. So it became in the past much more easy to make use of the digitalization. However, as Stefan also mentioned, digitalization is not necessarily connected to sustainability, because you also have an effort on the potential implementation of digitalization approaches. So coming to the approach of what is actually recycling 4.0, I want to take the perspective on the life cycle of the product, right? So here we have the linear material flows, starting with the raw material production, the manufacturing, to the product usage, and to the end of life. And then in all these phases, we have certain exchanges with the environment in terms of energy and water supply, in terms of emissions, and so on. So now bringing in the recycling 4.0 perspective, we can first say that the end of life stage tries to close the loops in different areas, right? So it tries to close the loop into the product use, which is a reuse perspective, or it tries to close the loop in terms of refurbishment, so bringing back components into the manufacturing, or it tries to close the loop in terms of recycling, so bringing back materials to the raw material production. So now, recycling 4.0 can be understood on the one hand side in a narrow sense. And here, this means that the digitalization advancement is necessarily, or is related especially to the end of life stage. So basically it means that you apply Industry 4.0 technologies, like for example data gathering approaches, to remanufacturing and recycling operations. So I will just give some examples on what this can be, right? So one example, for example, is the concept of a smart bin, where you have different sensors installed at the bin, which gives information on the filling status of a potential bin, and then this information can be used, for example, to give some information on the company which tries to empty the bin, and therefore processes can be made more efficient, right? So this is one example for recycling 4.0 in a narrow sense. Another example here is robot-based autonomous refuse handling. So you have a waste truck with an autonomous robot which picks up and empties trash containers, and then the robot also gets special data out of the container location and orientation from a drone. Just a second example. Third example, for example, is mobile weighing. So you can, for example, weigh the truck and the load of the truck, and directly get this information into further handling and support the end-of-life processes. Or you can use, for example, autonomous sorting, where you use AI-based product material recognition, so that you try to achieve a more efficient process in terms of sort out impurities, right? So these are just examples for recycling 4.0 in a narrow sense. A further example, or two more further examples are given here. So this is making use of a more or less social media platform, trying to collect waste out of in different cities. So we are, for example, in Braunschweig, a company that's trying to bring this information to people. Trying to let them make a photo of a certain area where waste is located, and so then a company can come and take up the waste. As I said, several opportunities. What we developed in order to make all these approaches a bit more, or to bring all these approaches into a bit more structured framework, we developed a framework which tries to match, on the one hand side, all potential technologies and solutions that result from Industry 4.0, and try to match those with the potential operations that are related to the end-of-life stages. So, right, so for example, you have in the end-of-life stage different process steps like collection, classification, test, reports, assembly, material separation, and so on. And on the other hand side, you have different Industry 4.0 technologies like data gathering, data mining, and so on. I do not want to go into detail for the moment. And now you can use that framework in order to evaluate which solutions from the Industry 4.0 sector are, let's say, potentially beneficial for a certain operation. And I will show how this can look like, for example, on the example of lithium-ion battery recycling, where we have a focus on, right? So the lithium-ion battery is quite a complex electronic product, where we have a high economic and ecological interest and also value inside the product. So it consists of various critical materials. We also have strict safety regulations, and there are mainly manual remanufacturing and recycling operations so far. So there may be a high potential to digitalize certain process steps. So what we did then was that we firstly evaluated potential Industry 4.0 solutions and technologies in order to support the processes in the recycling of lithium-ion battery. So one example, for example, is that you can use visualization techniques in the disassembly stage, right? Because you need to have the information on where is the battery situated, and then maybe you can give the worker that is doing the disassembly some more information on what has been happening in the past with the battery. Or you can use automated transport systems in order to transport also maybe damaged batteries from one point to another, or especially in the disassembly phase, you can use collaborative robots. So just one example or a few examples how you can make use of that framework. So if I now say that we have recycling 4.0 in a narrow sense, then obviously I can also tell that we have a recycling 4.0 in a broader sense. And I would like to explain what I understand with this. So opening up the perspective, not only to look at the end of life stage, but also to look at the whole life cycle of the product, we can argue that recycling 4.0 in a broader sense is providing support in terms of the digitalization of the whole product life cycle to support the end of life stage. So in this way, we create some kind of a higher level complex system, which is comprised of several other systems that provide information so that the end of life is supported in the end. So for example, you can give some information out of the manufacturing sector to the end of life stage, so that the end of life stage knows how the product has been constructed, right? So that is one option how this can be understood. So creating a circular economy system which interconnects different entities like certain circular economy providers or services, or that connects also customers, we can say that this kind of system analyzes and supports the understanding of all the interdependencies between all those different circular economy systems. And having such a system in the back, so it's more or less an ecosystem that we're trying to develop here, or that we're trying to talk about, it can be more or better understood if you have certain modeling and simulation approaches that try to say or tell you which connections do you have between the different actors, right? So this is important because you need to know which information is needed by, for example, the recycler, and which information can you make use of from the manufacturer or for the user. So you need some information on the system structure in the back. If you have such an ecosystem available, it's like having, or it's providing transparency and connectivity and real-time monitoring all over, so over the whole structure. And with this, we provide some kind of efficient structure. So maybe just to give some examples how I understand this kind of smart service platform for the circular economy, we can, for example, as I already mentioned, we can bring together manufacturing providers or manufacturers and end-of-life systems in terms of that we make a demand matching. On the one hand side, the end-of-life sector can provide information on how many end-of-life products will come back so that they can be reused for manufacturing system. On the other hand side, the manufacturing system can tell the recycling system how many products will go into the market. We can also provide some information on the required product or material characteristics, or the product and material composition, so that the end-of-life sector knows what they have to do with the product. Another example is related to remanufacturing, right? So where you can provide disassembly manuals, so for the end-of-life sector, so that they know how to handle a certain product. If we get back battery system, for example, they need to know how to handle the system because we have so many different systems on the market since standardization is, I would say, on the way in this area. So a disassembly manual can definitely be of help. Or we can make use of reverse logistics, or we can provide support for the reverse logistics so that we get some more information on potential product locations, right? So that has been shown on the example before. So this kind of platform provides information for different actors, for different scenarios or usage scenarios, and that is quite, more or less an integrated approach. If we look at existing systems on the market, we can say that currently, I wouldn't say that there's really an integrated solution that's providing everything. It's more like we have some certain platforms that cover some of these aspects. So for example, all of us know eBay, right? So an online platform for B2B customers, B2C and C2C sales in terms of used markets. We have other platforms like Rebuy, which is an online platform for used electronics and media. Or we also have platforms that are especially focusing on digital product passports. So like giving a passport of the construction of products and also buildings and so on. And then a certain other aspect, and also Stefan was mentioned that, where blockchain technologies are trying to be implemented to securely provide product information over the whole life cycle. So as I said, there is not really a final solution. It's more like there are certain solutions that try to integrate some of the aspects. If I come back to the end vision, so an ecosystem which tries to connect everything, I would say that this kind of ecosystem, and that's basically also my research area, creates a system of systems, right? So it's a system in which different other systems are interconnected in some way. And the question is, how do you engineer such a system? So which systems should be included? How should the interactions of these systems be designed so that in the end, the circular economy is not only supported, but also that sustainability is promoted, right? So because if we look, for example, here at this simple example, you have 3 systems, you can integrate those 3 systems, but it makes only sense if through the integration, you have a lower environmental impact than without the implementation, right? And so it's like, at the beginning, we have some kind of an independent system or a collection of independent systems. And the question is, how do we achieve a controllable and sustainable as a system of systems world? And how do we avoid an unchaotic or a chaotic and unsustainable collection of the individual systems so that in the end, we get a sustainable system of systems? And that's basically exactly what I'm doing in my research group, because we are trying to develop methods and tools to support exactly this research question and the design of these kinds of complex systems. So with this, I'd like to conclude. As I said, circular economy and cascading reuse of materials through the recycling can improve the environmental impacts of product systems. For the successful circular economy, information over the whole life cycle of products are needed, and the digitalization certainly can support here, but it should be reflected that digitalization is not necessarily beneficial. So you have to also evaluate whether the additional impact that comes from the digitalization is worth it in terms of the potential rebound effect. So the overall benefit of the circular economy depends definitely on the interdependencies between the different systems that you interconnect. And so we are trying to work on methods and tools to support the design of these kinds of systems. And I just want to make some let's say marketing for 2 of our projects here. So one project is dealing with the recycling 4.0. That's basically the main core, in which we look at the integration of production and remanufacturing into one facility, and look at the case of automotive batteries. And the second case, or the second project, is the project Efficient Use, Effizient Nutzen, which is funded by the German Ministry of Research. And here we're looking at especially at electronic products and trying to bring them into a more efficient cascade use. So not trying to bring them into the recycling stage, but to make them or to give them to the reuse sector. thank you very much for giving me the opportunity here. With this, I'm happy to answer your question and happy to discuss in future. Thanks.
Well, thanks a lot, Mark. I know it's quite a challenge actually, since you're doing a very broad perspective, and I know TU Braunschweig is a reference in your field, so you have a very broad area of research and you're covering a lot of topics, so it can be quite challenging to try to get across all of this in 18 minutes. So thanks a lot for giving the overview. And what we're going to do next is actually dive a little more deeper into a specific area. And so we're going to have a speaker from the Fraunhofer Institute. Fraunhofer is a society actually in Germany that is dedicated to research. It's a very traditional society. The institute that he's from in Berlin has been established over 40 years ago. And the speaker is going to be Marian Schlüter. Marian Schlüter is an expert in image recognition. He's been in this field within the last 3 years doing research on this very, very interesting topic. We're also working with this at the YES and also within the Institute because we think it's a very interesting technology. And it's basically about using convolutional neural networks, which is maybe more commonly referred to as artificial intelligence. You could also call it advanced algorithms. But in the end, it's about being able to recognize objects. And doing this basically with a specific device or even your smartphone. So you'd be able to recognize, for example, appliances or maybe components from electric appliances, and you'd be able to know who's the manufacturer, where did it come from, might it make sense to repair it, what is the brand, and so on. And so I'm very happy to have Marian here to share a bit about what's going on in his research within the last years, and also to share some of the projects that they've been working on. So Marian, very happy to have you here, and please let us know what's cutting edge in your research field.
Thank you very much for the kind introduction. And everyone doing good. Okay, so I'll start right away. I'm very happy to speak to you today about AI-enhanced identification, such as reporting system for reverse logistics. I would call it a way towards it's actually one of the applications that Mark just recently mentioned.
It's hard to hear you. Do you think you could stick a little closer on the microphone, maybe, if that's possible?
Okay. Do you hear me now better?
It's still a bit tricky, I guess. Not sure if it's might be connected to the headset or.
Well, I don't use my headset. But
Maybe.
right, is it now better?
Oh yeah, no, yeah, that's great.
Okay.
Yeah, now it's better.
Let's start again. I want to present to you today an AI-enhanced identification, inspection, and sorting system for reverse logistics. So it's an application of what Mark already talked about a few minutes ago. It's in the end of life of a product. And well, I'm working in the Institute of Machine Vision. And first of all, as you already mentioned it, I have to declare artificial intelligence for computer vision is not the whole broad research field of artificial intelligence where there are thousands of methods, but it's mostly machine learning methods that we use. And especially in computer vision, we use deep learning techniques. These deep learning techniques we apply on a daily basis in some research fields that I'm leading with my group. It's, for example, the image recognition or the object recognition. We use convolutional neural networks for this. We apply this to logistics, for example, for recognizing spare parts only based on images. Next, we use some regional CNNs that add also to the knowledge about what is in the picture, a knowledge where it is on the picture. And with that, you can see multiple objects on the picture. You can understand pictures more complex, in a better way. And you could also use it, for example, in quality assurance and get some defects of object surfaces, for example. And the latest we're trying to accomplish is that we try to use anomaly detection. That means we are learning just on the basis of good parts and try to detect an anomaly when a defect appears in a manufacturing process, so we don't need a lot of data to train our model. But today we came together to talk about the circular economy, and I want to give a perspective on reverse logistics and on challenges of reverse logistics. So Mark already mentioned the linear economy model, where we mine materials, make parts of that, combine them to products, sell those products to customers that use the products, and then they throw those products away, and it is maybe recovered the energy is recovered in burning, or it lands on a landfill. And we need to get away from this paradigm. So we try to close the circle, which is on this nice graphic. You can see on the right way, you have the product life cycles, where we want to bring the materials back to a manufacturer so that he can use it in the future. It's also important for Germany because we already import a lot of raw materials and secondary raw materials, about 60 or 40%. And we do that although we maybe have those materials already in our country, but we don't use them because they are kept still in products. So we have already, or Mark has already talked about some easy methods of the circular economy that is now used. For example, eBay. You have the reuse. If you don't need a product anymore, you can reuse it or redistribute it to anyone else that in this moment needs it. So the value is kept alive of the product. But if a product is defect and you need to replace it because you don't have time to wait for the repair, for example, for the maintenance, you buy a new one, and then the old one should be delivered to someone who repairs it and sells it another way. And this is called the remanufacturing. And this is where I also want to focus my talk today. Remanufacturing is already a working industry for automotive parts mostly. I don't know if you have been in this situation, but if, for example, your car breaks down, you can go to a workshop, ask for a replacement part, and the dealer would ask you if you want a new part or a rebuild.
It seems like he has a bit of a connection problem. Maybe just bringing in a few additional informations, I guess. And I'm hoping I'm not gonna be talking about things that he has included in his talk.
You have a high uncertainty in timing.
Oh, he's back.
And you have a high uncertainty in timing and quantity of incoming goods. If you want to handle with the tool of reverse logistics these amounts of flowing goods, this leads to a high complexity in reverse logistics. To rebuild such a part, you need the remanufacturing process. It is making used parts as good as new again. I brought you an example of cores. We also tend to call used parts cores. Here you can see a lot of generators or alternators of cars that are being fed into the remanufacturing process, in which a collection happens and the sorting of parts to which brand a part is corresponding and what its function is, and how it should be remanufactured or whether it can be remanufactured. Once this decision is done, we'll have a complete disassembly, a cleaning of each component, then we can build a new product out of several cleaned components, assemble it, test it, and sell it as good as new again. So this last steps, the disassembly until the packaging, is a special process for each product, but you have to have one general process that handles all the cores. So this is the collection and the sorting of used parts. And this is where reverse logistics come in. And this is also the topic where I and my research project with my colleagues from the Technical University of Berlin and Circular Economy Solutions and Architect focus on, which is the IBA project. This has the vision to combine all strengths of individuals in all strengths of the machine, of the worker, and of data. So the machine in this case will be an AI-driven combination of 2D and 3D data and of, for example, weight data from a scale, which is then processed and combined with the intuitive abilities of a worker, which is handling and smelling and also feeling if, for example, there are some loose components inside. And then we want to combine this also with data about previous deliveries to make the process of selection, of sorting, whether a part can be remanufactured and in which way it should be remanufactured, more efficient and overall more robust. So what do we do? What do we have to do in the collection process for remanufacturing? We collect the parts from, for example, the workshops in the automotive sector, and then they are delivered to a sorting facility where a worker, you can see it in the image right top, takes the part as it is now manually, looks at the part and tries to find the identification number in form of a tag, of a barcode, or a graved number into the surface material, for example. And meanwhile, he also looks at the part and looks if there are some defects. Is there corrosion? Is there something broken off? Or is there some parts missing? This he will type into the touch monitor you can see on the left to the worker. And the system will then tell him where he should store the the part he is handling at the moment right now, and whether it can be remanufactured according to his evaluation or not. This identification and reading of barcodes is not so simple as it seems in the first moment, because I brought a few examples to you. You have difficult lighting conditions in sorting facilities, you have a reflection, but most of all you have corrosion and damaged numbers that you cannot read anymore. Or you have some paint pollution that some workshop painted something over the numbers. And this is a real problem, because the identification of parts is nowadays only depending on those numbers. So if you cannot read this number, you will throw the part away and give it and pass it on to material recycling. So you do not have a value, your value will decrease with that action. The complex is also very big, so a worker cannot do it on its own and remember all the parts, because you have about 140,000 variants, which are coming out of 30 to 40 product groups, and you have 1 million parts flowing per year. So you have several workers in 3 shifts working all the day to sort those parts. Here's a few more examples of a pretty difficult identification task, for example. These two these two alternators with the yellow boxes look the same, but they are not the same because they have a different amperage and they have different current. So they have a different amount of copper, which you cannot see from the outside, and a human cannot differ by handling it. You have to read several more features than only the number on it. And right next to it, you have two alternators that really don't look the same, but they are corresponding to the same class. They are just taken from two different cars. So this is a really complex problem, and you need a lot of training, which needs a long time, which needs a long time for workers. We try to enhance this process by adding machine vision and artificial intelligence. So when the worker now takes his part, he puts it in front of a camera, in front of an image acquisition system, which takes 2D and 3D images of the object, and the learning algorithm in the back will recognize these parts and present a sorted suggestion list to the worker that he or she now only has to confirm if the first prediction is the right part. So if it's the corresponding part which is now in front of the worker or not. So we do reduce here now complexity from the problem 1 of 140,000 to 1 of 12 or 1 of 10 or 1 of 5. Also, we want to enhance the inspection process with machine learning and deep learning processes. Mostly, in the meantime, while the inspection process is ongoing, we already evaluate for typical defects like rust, corrosion, and missing parts, depending on the identification. And then we have a similar system. We can use those found defects, which also have local information of the image, and we can store it into a technical report that is now displayed to the worker. And the technical report says you have, for example, a lot of corrosion here, you have something dismantled here, and you have a housing damage there. The worker then confirms this report, and this report is stored with the evaluation of the worker, and the part is sorted on. So I mentioned that we are now 1 year in the research project, and by now we couldn't have implemented all of the things, but what we did is we tested the identification in a case study. So we took roughly 1,400 objects and digitalized them with images. So we had a setup, it's like a 360-degree photo studio image, and we took a few images of each part, 24 images to be precise, and we learned the system. We built a learning system and trained it. Convolutional neural network, state-of-the-art classification algorithms. And what we could show is that the algorithm or the network was able to classify 96% of the images correctly. That means out of that means we had in total 33,000 images. We took 60% of it for the learning. That means we had about roughly 14 images per object for the learning task, and we evaluated with about 5,400 images, and only 200 of them were classified wrong. So this was a pretty good result we couldn't think of in the first phase, but we're very happy to see it and to improve our performance later on. So what we can learn from that is that these algorithms didn't have to read any identification number. And this is also what we can take away from this presentation, because we showed that the identification, of course, is now feasible independent from text. That means now we can remanufacture parts without the need of identification markers. And this allows us to shift products by the use of digitization and artificial intelligence in the waste pyramid from recycling to reuse. That means we keep more value and we don't have to degrade products that will be in further use, in further life cycles. Another good effect was that the process is faster because the worker now does not have to type in the number and does not have to search the number, as well as the technical image-based reports support transparency towards customers. And that can also reduce reclamations if, for example, a customer is not happy with your evaluation results of the course they sent to you. The next steps in our research project will be to evaluate the joint action of all the artificial intelligence, the worker, and the data, which I excluded in this talk, but will be published later on. Yeah, therefore we want to gather real data from the real sorting station and not from a 360-degree photo studio, and we want to implement all of this into the process so that we gather the data in the process without disturbing the worker. And yeah, I thank you for your attention and give the word back to Philip.
Well, thanks a lot, Marian. It was very interesting to hear you. And I think there's one thing I'd like to use the opportunity as we're now able to enter the Q&A session, stick with you already and talk a bit about one point that you mentioned, which was you were giving a few numbers and you were talking about 200 false identifications. And at the first point, one might think, oh, so there's 200 mistakes still, so is the technology ready yet? Is it not? And I think it would be interesting to hear from you, and also mentioning to our listeners, I think that once you evaluate the efficiency of an algorithm, you should also compare it with the human performance, because it's not that the human performance in like the normal operations during like an 8-hour shift would be exactly 100%. So actually there's a threshold that is interesting to look, and I'd like to hear from you what's your perspective on this in terms of where the technology that does not only bring a lot of efficiency in the process, so you mentioned that and you talked about that you can save time while doing it the way you're processing it, but also there's a question of the accuracy compared to the humans. Maybe we're not getting to 100%, but we might become better than humans performing these tasks on a daily basis. What's your take on this?
Yeah, thank you for the question. So the human performance normally has an error rate of maybe 2.5%, something like that. That's not so much. It seems at the first look as if the human would operate better than the artificial intelligence, but what we cannot forget is that the human is dependent on tags. That means if you have a tag-based system or an identification number-based system, you always are dependent on those numbers. And if they are gone, also your identification is gone. And now with deploying these artificial intelligence algorithms, you can have additional products in your life cycle. You don't have to have identification numbers. Some parts do not have them at all, and they are at this moment no part of a circular economy because they are just put to material recycling because there's no chance to identify them at the end of their life.
Right.
So if you have 1 million, if you inspect 1 million cores, and you could say that almost 8% are not really readable. For example, you have 8% of 1 million that you cannot process in a year, and you don't have any chance to process them because there is no number you can read. But now you can process 96% of those 8%. So that's quite a lot more.
Right, that makes a lot of sense. Marian, also a more general question, which I believe is very hard to answer, but still, We know that there's a bunch of initiatives that are going on in this field. There's also a Belgium operator of a take-back system that's using or testing this kind of application to identify products in their reverse logistics. And in general, like one thing that I guess many people wonder, how much time is there left, how much time it's going to take until we might see this on a daily basis within our practice. Is this going to happen? We know that there's a lot of effort to train the algorithms. We also know that there's new technologies coming that might bring LiDAR technology to the cell phones, and so it might be more commonly available. What do you think in general terms, and I know it's a hard guess, but still you're the expert, what do you think how much time we're going to see down the road until this might become common practice?
Well, yeah, that's not easy to answer, but I could answer it with a rough guess, and I would tell that it's not 10 years from now, but it's more in a few years from now. Because by now you already have systems that work that way. For example, if you use Google image search, for example, or Pinterest visual search, or Amazon visual shopping, you have already systems that work that way. But those systems always have already a lot of data. You try to do marketing, you produce a lot of data about your products, and then you can use it. But in terms of technical components or technical devices, I talked about automotive components, you don't have that much image material, and you need to produce it during the process. So that's taking at this time the most time, I guess. Because you always say that 90% of the work of applying an artificial intelligence is engineering data and acquiring data. And then comes the last 10%, which is designing artificial intelligence and training it. So now we are in the phase of working together data.
I guess that also, I mean, it's always a bit related also to the cost of getting the technology down the road. And I'd like to connect that actually with Mark, that was, giving a fairly broad overview of initiatives that are happening at the Institute. And like one of the things that we often think, I think here in Brazil, once we have these new technologies coming from Europe or whatever, anywhere in the world, and if they're not invented here, which also happens, and there's a tendency to say, well, will it be, will we find an equilibrium in terms of costs and labor? In developed countries, the labor costs might be higher, so these technologies might be viable. Though still, within Europe, I think there's quite discussion in general in terms of like how these initiatives might be economically viable when you look at the cost of the technology versus the cost of labor in applying basically all these initiatives that were mentioned. So Mark, what I'd like to hear from you is, do you think within this portfolio of work that you're doing, are these initiatives economically viable? Do you think they'd be viable also to be brought to Brazil, given that the threshold is somewhat harder, so we have lower labor costs, and so it might make more sense to do work manually than like on a digital or automated way? What's your take on this?
Well, I think there is no clear answer, as always. So it definitely depends on the specific case you are considering, right? So you always have to evaluate whether a certain technology makes sense from an economic and also from an environmental perspective. When I refer to the projects that we are doing, we are, or more or less the main scope, for example, of the efficient use project is to develop business models, database business models that can be implemented into practice, right? So we are trying to get all the data that is necessary to establish processes that are potentially beneficial, but whether or not they will be adapted from an industry, this is certainly an aspect also which needs to be evaluated also after the project. But I can tell that the companies that we're working together within the project, so in the project this is, for example, Bosch and HP, so laptops and also general repair of electronic equipment. And they're definitely raising the question whether they may be interested in adopting certain aspects of the things that we're doing research on in the project. But that's also part of the project work to evaluate this as well.
Right. Well, it seems like we're sort of closing in on the time, so I'd like to do a last question to Stefan, which is, again, somewhat related to the topic, because what we often see when we talk about making circular economy viable, and people don't see it from an economic perspective, but more as a burden, like, oh, how are we going to deal with this? There are these new environmental policies coming, and are we going to able to, afford this? And so we've seen many countries being somewhat reluctant to adopt new environmental policies. And that is obviously also a topic in Brazil, but it's not also a topic in Brazil, it's also a topic within the European Union. And as you know, or you've been in touch with many of the countries that are dealing with the challenges that the European Union puts on them in terms of new directives that are sort of centrally mandated. Do you see, in terms of new technologies coming in and maybe the innovation cycles becoming quicker, the gap between these countries within the EU, is this closing? Are we seeing a more sort of consolidated framework, and might this be something that we can see as a positive result also to Brazil, because innovation might become more quickly available and the innovation cycles might be quicker, so we'd actually see much more progress and maybe much quicker progress, because technology is an enabler for that. What's your opinion on this within the European Union, given that there is quite a heterogeneous situation between even the EU countries?
Well, indeed, the point to environmental policies and circular economy is not to create red tape, but to actually contribute to sustainability, but also that there needs to be a business case. So, and it very much depends on how you also design your policies and also how you invest. You can actually reach a point where actually your economy is greener, but it also is more competitive. But also now, under the Corona times, we talk about resilience as well, and circular economy is also important for that. I mean, just think of critical materials. They are limited and they are concentrated in certain parts of the world. And for example, in case of Europe, it's very much dependent, but as I believe Mark already mentioned. So if we support circular economy, that could mean that we retain our materials from the urban mine in the economy, and instead of depending on materials that are in any case very limited in nature, and we need to keep them within our economy and use them smartly. Also, just not so reduce their intake, and also use them after the products become reach end of life phase. And so that is something that definitely you need to consider the economic aspects, and there needs to be a business case. Now, when it comes to the EU, definitely currently it's still there. Different countries, I mean, there is certain level of harmonization to be achieved, but it's important to now you see that there will be billions of euros actually are envisaged for the investments, including in digital, but also research. And this is something that could then also maybe help to some extent to transfer the technologies to other non-EU countries, and could speed the whole process up. It's hard to make hard predictions, but it's I would say that it is very interesting to think of this kind of a more like creating a single waste market in the EU as well, and that can support this kind of different waste flows to flow more efficiently between different regions and countries, but then again accounting for illegal waste management, let's say. That could create the economy of scale, that could support the deployment of digital technologies, and also, as discussed before, maybe then there is a bigger business case to use digital tools instead of relying only on manual labor. So they definitely need to tackle both angles, and it's important also for the public sector to support this transition and invest smartly in the research and development of tools of different new technologies, and also try to always mainstream it from the circular economy and sustainability point of view. And as time passes by, this is something that should positively also affect other non-EU countries.
Well, thanks a lot, Stefan, Mark, Marian. It was a pleasure having you in this session. Unfortunately, I'll have to close it because we're advancing on the time, but thanks a lot for your contributions and for making yourselves available to talk about the initiatives and the research that you're doing within Europe. And we'll be in touch later on to continue the discussion. Thanks.
Thank you.
Thank you.
I'd like to use the opportunity to make again a quick call on the donation opportunity that we have put out there on the Instituto Livres. If you can contribute, if you like the session, we'd be very happy if you contributed a small part. And I guess I can do now the transition, as we've been talking about innovation today, also in technology, mostly coming from Europe in this part. So we've heard a lot of topics and projects that are bringing innovation into the field. But Europe is not the only country that brings innovation, and we also have innovation here in Brazil. And what's going to be following is pretty much about this. We're going to see a video, I think, or an introduction of a recycling plant that has been set up in 2010 by the company Industria Fox. And it's going to show actually a patented process. It's been actually a global innovation by the time the plant and the way